Hello, everyone. You are welcome to our last lesson on indices and logarithm, related to core maths. So core maths, the last lesson on indices and logarithm. So the question before us, in certain situations, you will be told specifically, either directly or indirectly, not to use calculators to find values of certain log expressions or to evaluate certain log expressions. Okay, and when we don't want you to use calculators, okay, sometimes the log that we will involve, the values, okay, will be given, or the log that you will need, the values will be given. And it means you are not supposed to use your calculator straight away because somebody can use the calculator straight away to find this true or false. So immediately we do this, please, you are given this, don't use a calculator, whether you are told directly or not, don't use a calculator. Okay, so this will be the trick, how to deal with questions of this sort without using calculators or tables. So quickly, let's go and look at, okay, the solution. Okay, so as usual, questions are normal. We have to normal also. Yeah, it is normal. So let's see. Okay, we are supposed to find, okay, given this we extract. So write question 1. Okay, the information given there, we are going to extract. Okay, what are we giving? Okay, log the base 5 of code 0.4, okay, 307. And we are also to the log the base 3 of 5, or sorry, to the base 5 of 3. Okay, it's equal to 0.6, okay, 826. So we are giving these two log values. Let me try this. Looking. Okay, I've told you avoid it. Can erase, but this you will have to cancel. So log the base 5 of 3. Not what we have here. So now we come to A. A, what are we giving? Okay, log the base 5 of 50. And this is all that. Look at the bases given. Oh, the other one was, okay, so look at bases given. You are giving base 5, base 5. This is also base 5. So you thank God. Then you can see that here you are giving base what? 5 of 2. So the numbers that are taking log of that you are giving. So you try to express, okay, the number that you are taking log of in the question that you are supposed to, okay, evaluate using whatever that you have there. Write it in that form. Take note. Write it in the form, meaning the product of what the form that we call products of factors involving these two numbers. So can I write, okay, 15, okay, as to contain only 2 and what and 3? Should I come again?
Yes, please.
Okay, so this is my point. Okay, we need to write this one as a product of numbers. The numbers should involve either 2, 3, or both. Because when you split, if I write it out as a product, I'll use the product rule to split. So all of them will have the basis to be 5, the log base to be 5. So it will be maybe 5, okay, log to the base 5 of 2, which I am giving its value. So I can substitute log to the base 5 of 3, which only I'm giving its value. Okay, so please take note. You are struggling to get the numbers right.
Yes.
Because of the first information that I gave you. Okay, so either 3, 5, sorry, 3, 2, or both. But take note, if you can also involve, okay, the base here 5 involved, because you should know any number to the base 5 of 5. So that is a property. This one. Don't need the cap. Is that clear?
Yes, please.
So it means now if you have this idea, it means you can write this one as 3 times what? 5. Am I right?
Yes, please.
So always consider the base as one of the numbers. Okay, so here the original numbers were 2 and 3. Now we will add the base as well. So 5. If I can write it to involve 3, 2, and 5, I do that of any of these 3 numbers. Is that clear?
Yes, please.
So I'm going to get this to be equal to, okay, log the base 5 of what? 3 times 5. All correct. So
Yes,
we
please.
know per the algebra, log A times B will give us log of product is the log of sum. Am I right? The sum of the log. Am I right?
Yes,
So log
please.
AB is equal to log A plus log B. So this will be equal to, remember this one, its value has been given, which is this. So 0. Okay, 68, okay, 26, then plus, okay, your log, this one will be 1. I hope you are with me.
Yes, please.
In effect, I'm going to conclude by saying, therefore, log the base 5 of 15 will be equal to, this plus this will give me 1.16. That's clear.
Yes, please.
Hello, my professors, are you following?
Yes, please.
Okay, very good. All right, so let's go and look at the other one too. Okay, what are we giving? Okay, log to the base 5 of n. Okay, so this is an expression. Okay, now remember the numbers that we can involve in our products should be 2, 3, and 5. So let's see if you can deal with this one that way. Okay, multiples of, okay, 2, 3, then 5. Any of them. Let's see. Okay, so you can write 10 as what?
1 times 2.
Okay, so 2 times 5. It doesn't really matter how you write it. Okay, so let me write, okay, 5 times 2. So this will be the same as what? Log to the base 5 of 5 plus log the base 5 of 2. All correct.
Yes, please.
Okay, which will be equal to, okay, so it will be equal to log to the base 5 of 5. We all know that is 1 equal B. Then plus log to the base 5 of 2. That is given as 0 point what? Or 3, okay, 0, 7. So it means I'm going to get, therefore, whatever that I was, just log to the base 5 of 10. Equal to this will be 1 plus this, which will be 1.4307. I'm done. All correct.
Yes, please.
Okay, so now let's go to the decimal. Okay, so you know all the questions are carefully selected. So now log, I can choose not to write it. So for once, I'm going to do that. 4.5. So this will be equal to log the base 5 of, write the 4.5 to its corresponding fraction, reduce fraction. So I'm waiting. That will give us 9 over 2. Am I right?
Yes, please.
Okay, so this will give us 9 over 2. Okay, so in effect, this is going to give us log to the base 5 of 9 minus log to the base 5 of 2. Do you agree? Hello, do you agree? Especially Akosia.
Yes, please.
Okay, very good. So, like I said, I'm avoiding the here. Let me clear it and write it well. So, and now they are in the pole position. Yes, whatever that. So, in this case, you know, this 9 here, you can write it as what? As 3 squared. Is that not it? we involve the product of the numbers that's either 3, 2, or 5. So this will give us log to the base 5 of 3 squared. Okay, someone can write 3 times 3 and later break it down as 3 plus what log. Okay, log to the base 5 of 3 plus log to the base 5 of 3. Okay, it's the same thing. Okay, so minus log to the base 5 of what of 2. Okay, I will do the substitution at the same time. So the 2 can come down. Is my point well made? Okay, so now we can comfortably go and carry out our substitution. That will give us 2 times what? Log to the base 5 of 3, we are told is 0.6. Okay, 8. Okay, 2, 6. Then minus log to the base 5 of 2, and that is 0.4307. Okay, so now you know what to do. The calculator will help you here and minus. So I'm waiting for the answer here. At this point, if you use your calculators, no worries. Is that clear? So I'm waiting.
1.3652.
Come again.
1.3652.
For this one,
Yes, please.
1.3652.
Yes, please.
Okay, so now, therefore, okay, log, okay, to the base 5 of 4.5. Okay, will be equal to do the subtraction, then give me the value.
0.9345.
0.9345.
9345.
Okay, as simple as that. Is my point well made? Okay, so probably maybe I will add this one, okay, to your assignment. And maybe this will rather be your class assignment or whatever. But let's move on. We are working time. Any question before we move on? Any question? Okay, so we are all fine. We thank God. So quickly, let's go and look at another question which involves, okay, the same concept. So question 2, given that log to the base 10 of 2 is equal to this, and log to the base 10 of 5 is equal to this, evaluate correct to 3 significant figures this. Do you have any salient parts that must be underlined in this question?
Correct to 3
Which is, yes, so correct to 3 significant figures. So I'll underline 3 significant figures. Very important. So it means if your answer is not in 3SF, okay, you are wrong, or you'll be marked down. So as usual, yeah, I'm going to extract, okay, what we have here. So I'm going to write, okay, given, okay, log to the base 10 of 5, sorry, of minus log 10 of what? Of what? Okay, remember the numbers that we are taking log of, then 5. Do you have any other possible number to consider apart from 5, based on the advice you are giving? Any other number to consider in the product? Hello, my professors, are you there? Any other number based on the advice? Remember, I said also consider your base as one of the numbers. So now, if you have that, quickly, let's go. Okay, where we need to substitute, pick it in. Substitute. So 50, you are going to write that one as what? Can you write it to involve only 2 and 5? It could be 2 to power something. Okay, you can use your factor tree if need be. So you know, first of all, start with the original numbers. If it's not possible, then you bring in the 10. So I know I factor three, I'm going to get what? times what? 55, am I right? And this will give me 5 times 5, is that clear? Hello, are you with me? So it means I can write this one as log base 10 of what? Of, okay, 2 times what? 5 squared. All correct.
Yes.
Okay, so I'll write this one. Somebody can also write 2 times 5 times 5. Okay, however, if the person writes it that way, then when breaking it down, the person will write log to the base 10 of 2, log to the base 10 of 6, plus log to the base 10 of 5. However, if you write it this way, we are going to get log to the base 10 of what? Of 2, then plus your other factor is 5 squared. So log the base 10 of what? 5 squared. All correct. Okay, you have a square there, which you can substitute here, only that I always want to substitute. Okay, at the same time, so if I'm substituting for this, I'm substituting for this one as well. All the terms are the same. So this will be 2 log the base 10 of 5. Do you agree? Okay, however, I've been doing log to the base 10 of 2 0 point. Okay, 0, 1, 0 plus. Okay, 2 times log to the base 10 of 5. That is 0.6990. All correct. So at this point, just straight away go and use your calculator. Okay, make sure all your terms, okay, as 0.3010 and plus. Okay, just multiply. So I'm going to do that here. Then you come and draw your conclusion. Hello, I'm waiting. Hello, 2 times this. Can you hear me? Hello, can you hear me?
Yes.
Okay, so I'm waiting for
1.398.
1.398. 1.398. Okay, so therefore, log base 10 of 50, okay, minus log to the base 10 of 40, okay, is equal to, so sum these two and give me the result. I'm waiting. It will be 0.6990. Oh, sorry, 1.6990.
0, no, 1.69.
6990.
6, yes, please, 699.
Okay, so 1.6990. Okay, so this then becomes, unfortunately, you can see that. Can I conclude with this? Okay, so I cannot conclude with this. So you have to be very, so at this point, remember I have underlined. So I will subject this one to what I've underlined, and I will realize that I cannot conclude with this. So though I have ended here, I won't cancel. I will move a step further and come and write equal to. Okay, then now convert this one to 3 significant figure. Your first significant, second, so your third. If you add one, this is fourth. You add one, you are going to get 10 here. You add one, you get 7. So you get 1.70, and you put bracket to ASF. Akosia, your hand is up.
Mr. Akman, please, what you've done, is it for log base 10 it's 50, or for log base 10 it's 50 minus log 10
Which
base
one?
10 into 4? Your conclusion.
No, no. did only one term. I did only one term. So it means all that we've done here is wrong. I considered this. I don't know why I did this. Okay, I should have come and work on this one as well. So let me do the right thing. Forgive me. Okay, forgive me. This one is serious, and I don't know why. Okay, I left out this. So what I'm going to do is we'll add it. Don't worry, no issues at all. Okay, so obviously what we've done here is for this one. We haven't done the second term, so minus. So I'm waiting. Minus this one. Can we write? I said go and break it down one also. So 40, you get 2 times what? 20. Am I right? And this will give you what? 2 times 10. This will give you what? Okay, 2 times what? 5. So it's like we are going to get what? Log, okay, of what? To the base 10 of 2 cubed. Okay, then times what? 5. Is that clear?
Yes, please.
Okay, then this will give us minus. This is where you have to be careful. So minus, we are going to get log, okay, because this will give you 2 terms. Log 10, okay, of, okay, 3, 2 cubed, okay, plus log, okay, to the base 10 of 5. As you mature, you can remove the bracket straight away so that you know that each of the terms is clear. I'm going to get minus, okay, so take note. This will give you, this will come down. I'll get 3 log base 10 of 2. Okay, then minus, okay, log base 10 of what? Of 5. So from here, our algebra would, okay, so because we can obviously see items, is that clear? Hello, are you with me?
Yes, please.
So we will not substitute directly. We'll combine like terms first before we substitute. Is my point well made? Okay, so I've cleared what's needed to be cleared. Okay, so don't directly after in this check if you have like terms. Okay, so this will be equal to log to the base 10 of 2. Okay, log to the base 10 of 2. Have another one here. So I combine this, I'll combine the coefficients. 1 minus 3, and that will give me minus 2 log to the base 10 of 2. Clear. Hello, is that clear?
Yes, please.
Okay, however, it is a negative term, so I will serve it for the time being and see whether the other one will be positive. I'll write that one first. Log to the base 10 of 5. Yeah, I have another log to the base 10 of 5. But only that is minus. So it will be 2 log to the base 10 of 5, just like 2x minus x, and that will give you what? X. So you log to the base 10 of 5. Is that clear? That is positive, so I'll write that one first. Then minus the other one, we give you, okay, log to the base 10 of 2. Is that clear?
Yes, please.
Okay, so which in effect going to give us this will be equal to, so at this point, and carry out our substitution. That would give our log 10 of 5 is this, so 0.6990. Okay, minus 2 times log to the base 10 of 2, and that is what 0.3010. Okay, so this will give us 0.6990 minus, multiply this. I'm waiting. Hello, I'm waiting.
0.6020.
You had what?
6020.
0.20. Okay, 20. All right. Now we know. Okay, that at this point we can draw out. I'm going to squeeze pipe. Okay. Therefore, Okay, my log to the base 10 of 50 minus log 10 of 40. Okay, will be equal to, so I'm waiting for the final answer again. I'm waiting. You know the calculator work is for you. So,
Mr. Hoffman,
yes, have I done something wrong again?
please, with the third step, you had log to the base 10 of 2. Then you subtracted the log to the base 10 of 5 from there, 2 log to the base 10 of 5.
Which one? The third step,
Minus,
what is this?
yes, please.
Mhm.
Moving on to the fourth step.
So this one, I combine like terms. This and this are like terms. Can you see that?
Yes, please.
Same basis, same number that. So if you combine, it will be 1. The coefficient here is 1. 1 minus 3, and that will give you minus 2. But I said, let's hold on. Because the other one, realize that it's positive. That one. This and this are also like terms. So that gave us this.
Yes, please.
So now give me the value. Give me the value. I'm waiting. I just realized that again, we cannot conclude. So let me. However, if you write it this way and you draw a conclusion, like I said, okay, don't cancel. Just go and write equal to again. Okay, then write your approximated value, that the required approximation. So I'm waiting. So this will be equal to give me the raw answer. So your answer must also be 4D because your values here are given in 4D. Write all of them in 4D before the convenient approximation. So I'm waiting. So the required approximation rather not convenient. Oh, give me the value of this. Hello, can you hear me?
0.097.
0.097. So 0.97. Please, because this is 4D, always make sure it's 4D. Other than that, you give us the that you use your calculator. So that if you use your calculator, no issues. So if you get 3, add 0 to it to make it 4, because what you are dealing here are all 4. It means raw 1, but the calculator will ignore this. So now you come and draw your conclusion. Therefore, okay, your log to the base 10. Okay. Oops. Lights out. Minus log to the base 10 of 40 is equal to 3 significant figures to give us, okay, this is the first, the second. Okay, will this be significant? Okay, it will go, but okay, it has come. The light has come. Okay. So I believe my network will go. So please, hey. So please, okay, let's continue. The light went off. Okay, so we have it back. So now I was waiting for the approximation. We said, okay, 3 significant figures. So if you are, this is the first significant, the second. Will this be significant? Okay, you let me write the answer if you don't want to mind. So that will give me 0. Okay, 9. Okay, sorry, 0 0.0, 0 0.0, okay, 970. Okay, let me clear it and write it well. Please, are you following?
Yes, please.
Okay, I think that was saved. Why is it not going? Okay, so that was saving, so it will not go unless I go the number. So 0.0970. So it means even the other one, if you had concluded, okay, would have ended up drawing the same conclusion. However, don't forget to indicate your approximation. So you put it in brackets here. Okay, 3 SF. It shouldn't interfere with this rough work. Unfortunately, I couldn't clear that. So that will be it for this kind of situation. Okay, without using tables or calculators, and you are given, that's how you deal with it. So here, my major concern is this. When you know your product here, you are dealing with more than a number, more than one factor, make sure you put it in brackets so that the negative will come and affect all the terms. If you ignore the brackets, you are doomed. Is that clear?
Yes, please.
Okay, good. All right. So now to the last set of questions. Okay, another kind of exponential equations. Okay, it's similar to what we did in the elective math. This question, you can get it in both core and elective. So I'm teaching you this under core. Okay, because all elective math students do core math. So now let's go and look at, okay, the best way to deal with this. Okay. All right, so we are supposed to find F. Okay, sorry, X, if A. So let's go to A. Okay, what are we giving? So we are finding X. Okay, so giving 3 to the power X, okay, plus, okay, 3 to the power X plus 1, okay, is equal to 36. Okay, so I've told you, anytime you realize that you are dealing with sum, if you are dealing with product, the work becomes very easy. Then it means you have to write this as a common base, then check whether you can write this also as a common base. Okay, the same base as this. Then you compare the exponents. If you cannot write that to be the same base, then you take the log. You remember? Okay, so you know you have all the tricks. But with this one, you are not multiplying, you are adding. So where you are adding, we had a situation where we were adding, okay, and the bases are not the same. But if you are adding and the bases are the same, and you realize that each exponent is linear, okay, or the exponent of your bases, your terms, okay, they all have the same degree, then it means likely, okay, you are going to get like terms to combine. So in this case, this is what I mean. I'm going to write this one as, okay, 3 to the power x, I will maintain it, plus, I know this is the same as what? 3 to the power x times 3. Do you agree? 3 to the power 1.
Yes, please.
Okay, so in effect, I'm going to get 3 to the power x plus 3, okay, into 3 to the power x. Am I right? Which is equal to 36. But you can see that these two terms are like terms. Can you see? This is the same
Yes.
as 1 into. So this will give me 4, okay, into 3 to the power x. Okay, and that is equal to what? 36. So what do? I divide through by 4. So I'm going to write 3 to the power x, okay, the whole of this times 4 all over 4 is equal to 36, okay, over 4. Okay, so 3 to the power x will be equal to what here? Hello, it will be equal to what?
9.
Come again.
9.
9. Okay, so obviously you know that now you are dealing with, okay, proper exponential where you can write them. So x will be equal to what? 2. So therefore x is equal to 2. Okay, in this situation, let's go and pick that of the b. Okay, so the b2 basically is the same thing. So 2 to the power x giving plus what? 2 to the power x minus 1 is equal to 48. So once the bases are the same and they are adding, okay, the power is linear. So it means they are like terms. Okay, so I will write it, okay, so that they will obviously, I will get the coefficient to add because the powers here are not the same. So I will get 2 to the power x over 2 to the power 1. Okay, and it's equal to 48. Is my point well made?
Yes, please.
Okay, so at this point, again, I can clear the fraction. So that will give me 2 into 2 to the power x. Okay, plus, okay, the 2 will cancel. So plus 2 to the power x. Okay, it's equal to This 1 times 2 will give me 96.
Yes.
Okay, so these two are like terms. 2, okay, in bracket, 2 to the power s plus 2 to the power s will give us 3 into 2 to the power x. Am I right? And
Yes,
that is equal to 96. So you can write it again, then you divide. Okay, so over 3 over 3. Okay, so we get 2 to the power x is equal to what? It's equal to,
32.
come again. It's equal to what? Ah, you people, are you hungry?
48.
Okay,
Is
so
that
48. Okay, so let's see, can we write 48 as a base 2 to a certain power?
this is 32.
30.
30.
No, how can
32.
this? It's over 3, not over 2.
Yes,
Please take note. It's over 3, not over 2. So obviously it cannot be. Okay, 48. So it's supposed to be 38.
32.
32. Okay. Can we write this 32 as 2 to a certain power?
Yes.
Okay, so we are going to get 2 to the power s is equal to 2 to what power?
5.
2 to the power 5. Okay, so therefore x will be equal to what? 5. Is that clear? Hello, is my point well made?
Yes, please.
Yes.
Okay,
Yes.
so on that note, if that's the case, any questions? Are you sure you are fine with? So you should be able to, okay, recognize the type of equation and how best to deal with it. If in this case, okay, we had the base here not to be 2, I mean to be different, okay, and the exponent also to be different, then we'll go the relative math approach. Take notes. Where you write, then you write, let this be equal to, then you go and solve. But immediately you realize that your terms, the bases are the same. Okay, and the exponents, they have the same degree. Then it means they are like terms for you to combine. Okay, then you divide through, you reduce it, then you go back to your usual exponential equation technique. Is my point well made?
Yes.
Okay, so on this note, thank you very much. Okay, and God bless us all for making the class a success.